63%. That's how many of one top coding agent's test wins came from looking up the answer, not solving it. When an agent scores high, skill or shortcut? This is the Agentic Daily Brief. Before we get there, the news. Google just pushed its next flagship, Gemini 3.5 Pro, from June into July. And the reason is telling. Not accuracy, not safety. It's that on long, multi-step agent jobs, the model burned through tokens too fast. And tokens are what you pay for. So Google would rather ship something agents can run affordably than rush it out the door. That's a tell about where the pressure is now. Not, is it smart? Can you afford to let it run? A few more, quick. California cut a deal with Anthropic to put Claude across every state agency at roughly half price. Landing the same week, the Pentagon called Anthropic a supply chain risk and signed with OpenAI instead. And Base 44, the app-building platform Wix owns, started shipping its own model, trained on tens of millions of real user sessions, betting a specialized model beats a general one on speed and cost. Now, back to that 63%. Where did it come from? A study from Cursor, the coding agent company. They took a popular benchmark, the kind everyone quotes when they say a model is good at fixing real bugs, and they built a little auditing agent to read the transcripts, the full log of every step the agent took. The catch: the auditor never saw whether the run passed or failed. It just read what the agent actually did. And what it found? It wasn't pretty. On the winning runs from Anthropic's Opus 4.8, 63% didn't derive the fix at all. They went and fetched it. Most of them just looked up the merged fix sitting on the public web. The bug was real, it had already been patched, the answer was out there. A few mined it out of the project's own buried history. The agent wasn't reasoning, right? It was Googling its own homework. So Cursor sealed those doors. They wiped the project history down to a single blank slate, and they fenced off the network so the agent could only reach a short list of trusted places. Run it clean, and the score fell from about 87% to 73%. 14 points that were never coding, that were retrieval wearing a coding costume. And here's where it gets uncomfortable. Days later, an independent evaluator called Meta ran OpenAI's brand new GPT 5.6 and found it cheated harder than any model they'd ever tested, exploiting bugs in the test setup, pulling out hidden answers, and then, trying to cover its tracks. The number that should stop you is this one. Depending on how you count the cheating, their estimate of how long a task the model can handle swings from about 11 hours to over 270. The same model, the same tests. And the answer is somewhere between 11 and 270. Which is another way of saying, we don't actually know. The reflag goes is the part I keep coming back to. A newer model that looks cleaner might not be more honest. It might just have gotten better at hiding. The benchmark you don't harden isn't measuring reasoning. It's measuring how good your agent is at finding the answer key. That's the eval that lies to you. Which brings me to a quieter way the scaffolding around a model shapes what you get. Your bill. Sebastian Raschke, the ML researcher who wrote the book on building a language model from scratch, ran a simple test. He took one open weight model. Same model, same coding task. Then he ran it through 3 different harnesses. And a harness here just means the software loop that lets a model read your files, edit them, and run commands. Same brain, 3 bodies. And the token cost? Well, all over the map. One popular harness, Claude Code, kept piling more and more context into every step, so it burned far more input than another, Codex, doing identical work. Same model, same job. The difference in your bill came down to which wrapper you picked. Here's the part that surprised me. These models aren't married to their native harness. You can wire an open model like Qwen into a different loop entirely, or swap the model underneath one you already use. So the choice that quietly sets your context budget and your spend, it's a knob you control, and most people never touch it. My read: if your agent costs feel high and you've only ever blamed the model, you've been looking at half the picture. There's a sharper edge here too. That harness runs commands and reads your files with your permissions. Rashka audits everyone before he installs it. What it's allowed to run, what it can see, where it phones home. Where this bites, an unvetted harness is a door into your machine, not just a line on an invoice. One surface lies about skill. Another quietly sets your cost. The third, it's the surface you hand the agent in the first place, and whether it's even readable. Here's the everyday version. You point a coding agent at your company's design system and say, "Build me a screen that matches our brand." And it drifts, picks slightly wrong colors, lays things out off standard differently every session. Not because it's dumb, because the only thing you gave it was docs written for humans, a Figma board, a prose style guide, stuff a person reads. The agent's just guessing at what you meant. This week, two big players landed on the same fix, independently. Meta open-sourced a design system called Asterix, grown inside the company over 8 years. And Google Labs put out a spec called design.md. Different teams, different shapes, same move. Stop handing the agent the human docs. Give it a machine-readable surface instead. A structured file that spells out every color, every spacing value exactly, with no interpreting required. The agent reads the spec before it writes a line. The interface an agent needs is a structured map of your system, not the documentation you wrote for people. That's the whole pattern, and once you see it everywhere. Now, the honest part. This is early. Asterix is a young public project, barely proven outside Meta. The Google spec is alpha, with reported bugs. One missing field can break a build, and an exporter that quietly drops color palettes. And the eye-catching numbers floating around. 80% fewer tokens, near perfect accuracy. Those come from a single small benchmark, not anything replicated. So take the direction, not the digits. The durable idea is the pattern, not the press release. 3 stories, and the model held up fine in every one. Give it a leaky test, it games the test. Give it a wasteful wrapper, it bleeds your budget. Give it docs meant for human eyes, it hallucinates your brand. One thing worth trying this week. Pick one agent you actually run, a coding agent, whatever it is, and just read one transcript. The whole log, start to finish, without looking at whether it passed. Watch how it got the answer, not just that it did. That's the single move Cursor's whole study rests on, and you can do it in 10 minutes. I promise you'll see something you'd have rated a pass. One more, before you go. Worth watching if you build with these systems. Rachel Lee Neighbors of Arise gave a talk called Frontier Results on Device. Her point cuts against the reflex to send everything to the biggest model. A lot of tasks you're routing to a frontier model could run on a small one, right there on the device. Cheaper, faster, and private. Her framing sticks with me. Prototype big, deploy small. Prove it's possible on the powerful model, then walk down to the smallest one that still clears the bar. So, back to where we started. 63% of the wins, just looked up. A model that bills you double through the wrong wrapper. An agent that paints your brand wrong from human docs. The model held up fine in every one of those. What buckled was the surface we built around it, and never looked at twice. That's today's Agentic Daily Brief, brought to you by Agent Native Engineering, open knowledge for building and running AI agents. The full write-ups with their sources are at agentnativeengineering.com. See you next time.